Alright, let's talk about cameras. This is something that I'm particularly passionate because I do game development, and this experience is particularly handy when I go to experiences like hackathons and I'm learning to get certified for a specific software. So, this is something that I believe all people should know how the tools that they use actually work, it runs whatever 3D software that they use. And one main component for viewing what we see is rendering and the cameras that do it. And this is particularly about virtual cameras. So let's start. When you have a camera, it typically views any objects within what it's seeing. This camera right here is seeing this object. We'll call it OBJ1. OBJ1 is rendered within the camera's viewport, like this. There's a little bit of perspective because it's a 3D camera. I'm going to be dealing with 2D cameras for right now, but it's still going to have the same concepts, so you can tell when exactly something is doing as it's supposed to. And as you can see in this little simulation I created in Scratch, the player is able to move on all directions, and its velocity determines how fast and how far it moves within that particular moment. And so this is when we're rendering a player. So this would be for a 2D camera. A 2D camera would probably look something like this. The camera is looking downward, okay? And this would be the ground. Let's give it some grass. And the player's over here. Okay. So if that's a player and that's the camera, this thing up here, then it sees everything in a top-down perspective, just as this little scratch project is here. And if we move the camera, we expect the player to remain in place, although since the perspective would now be shifted like this, we'd see only half of the player. So let me enable the camera really quickly. Now that the camera is enabled, if we move the mouse, the camera's offset is determined by the mouse. So moving, as you can see, the player and the map don't seem to move in regards to each other because they themselves are stationary. And if you look at the code, then it's quite obvious why. Uh, Let me open the code a little bit. Okay. The code should now be visible. So when the camera is on, the player will go to where the camera is offset on the X and the Y. If not, it'll just go to the position it's supposed to be in the world. The map does something quite similar. It goes to the player X times -1 because when the map is moving, it should move in the opposite direction to indicate that it's scrolling, and then it'd be offset by the camera. And since both the player and the map are offset by the camera, no matter how I move the mouse, the player and the map will not move in regards to each other. This is effectively demonstrated if we add in another variable to the mix. So let's try making the camera offset independent of the player. So if we no longer change the camera offset, the camera, as you can see, is moving on its own. So if we change the camera offset by something else, so we set the camera offset to 0. We set it to a new variable called cam and cam y. So we'll set it to cam and cam y. cam and cam Y over here. We'll make this a slider. Okay, good. And then we'll change the slider range to negative 180 and the maximum to 180. And the camera Y will be the same. Actually, we'll do, 180 and 180. Good. So now, if the camera is on, it should, that's strange. The camera's on. Okay. Camera offset Y. Good. Now the camera is moving independently of the player. So if we move the player and we change where the camera is looking, then it no longer looks at the player. And this is because although the camera is tagged to the player, the offset is working independently of the mouse position and of the velocity as it had before. We can use a um, variety of offsets and presets to create extremely complicated camera systems. And I'll show you one in just 1 second. This is an older project that does a very similar thing to what I just built, except as you can tell, it is probably much better in terms of quality, and the math behind this are quite complicated. I did my best to document it, although it's not great. As you can see, how far away the mouse is to the player is changing the zoom. It's going to be much easier to notice the effect if we make this no longer visible. The camera is zooming quite strongly, actually. And there are a lot of variables defining the zoom and how the camera is offset from the player. And each weapon that I've coded into this older project is corresponding with its own zoom value. And moving the camera, you can see that it all works very nicely. And this is the beauty of a camera system. Once you create it, you set the zoom, the offset, and the player X and Y coordinates. You can just change it to whichever direction you want. And it's quite simple to build the basic system, as it's quite similar to creating something that doesn't scroll. You just have to move the map instead of moving the player. That's all I had to say for um, the math behind cameras. And there's a few tips that just wanted to share. If someone's creating a camera system, you should probably normalize the input. Normalization right here of a vector. Basically, when you normalize a vector, you take a vector and divide it by its own magnitude, so it gets reduced to being stuck to a circle. The vector's starting point and the ending point will always have the length of 1. It'll be reduced to a unit vector. And this is so that you don't have bugs where the player is able to move faster if they're moving diagonally. This bug is often found in games where you can move faster if you strafe. And my other projects completely circumvent this issue by dividing out how fast you move in the direction that is diagonal to the X and Y axis. And another thing with zoom is that you want to make the zoom dynamic. If the zoom changes for reasons that are outside of the control of the player, then it will seem as if the entire project is not working smoothly. I'll show you what that looks like in just 1 second. We'll reload the project, and as you can see, the zoom is still affected by the distance, but absolutely nothing is happening when we move the character. And this is and changing weapons still um, affects the zoom. Oh, and that's also what happens if you have bad math. It will make the parameters completely out of line, and it'll look weird. And now, changing the weapons doesn't even do anything. And at this point, there's no point of zoom. As you can see, there's still a tiny player there, doing what a player would do. You want to make anything that you do, you want to make it dynamic. And that is basically everything when it comes to cameras and the math behind it.